Okay guys, finally I think I might have solved the background voice problem, and in this video we'll cover the complete what is that model question paper. So basically in this PDF you can say there is 79 pages, but don't get afraid that, oh, what the hell is 79 pages. From what I will say, it will be very simple. See, every page, like many things are in big or to say font and all, but don't worry, just understand that this thing, the beginning few questions are very big, but I will tell you with the help of this highlighter. I'll highlight with green. Okay, let it be take text only highlight. Yeah, let it be on. Okay, so now what I'll do, I'll only mark the important things which you have to remember. So here you can see there is a reference, so you can understand from which it has been taken. So now for all the questions, I will tell you what is important, and if you just note down those points and read the few explanation of those points, it's more than enough for you to answer the examination and get full marks. Okay, so here the first question we had in the question is, what is big data? Explain the challenges with big data. So in the big data, first you have to talk about this normal big data, like very huge, enormous and all, but actual definition is here. You have to tell that big data is high volume, high velocity, high variety information asset that demand cost effective innovations form of information processing for enhanced insights and decision making. So this is the actual and most important what to say definition. Along with the definition, you can explain what is mean by high volume. In the sense, a large amount of data is being always generated 24 by 7 in the world. That volume is like enormous volume of data is always generated and all. High velocity is the speed at which this volume of data is generated is very high. So like everywhere 24 hours, and like billions of tweets, billions of posts and all, so much like high different type of like structure, unstructured, semi-structure, like the end all. You have to talk about that. See here, it has actually given a big answer for this, but you don't have to worry. Don't worry that it's not like a random chat GPT answer. It is from AI, but it was all taken from textbook, so you don't have to worry anything. So just see, look into it. Small things where you have to say. So I told you, right, high velocity, variety. Additional things that you just mention and just write one example. Veracity is all about trustworthiness. Validity is correctness and accuracy. Volatility, data shelf. Volatility is like, you remember, right? It's volatile in the sense what it might evaporate after some time. So it's not permanent, like time temporary type. After like 24 hours, it might automatically. So you have this WhatsApp disappearing messages. Variability, flow consistency. So enough. Then actual is all the challenges. So this from here you have to remember all. It's capturing the data in just like collecting the data, gathering the data. Once you gather the data, how will you store the data? Once you have stored the data, it's all junk and all. You have to remove the junk or unwanted data. So that is data cleaning. Searching. So since you have this huge enormous of data, how will you search it? That is the problem. Okay, so that is a challenge. Fast indexing and retrieval management, that is also a challenge. Since the data is huge enormous and amounts of billions of data, how will you find only one thing, one MB of thing like that? Analysis, since it is so huge and all, how will you analyze the data? Traditional articles are very problem, so you have to. So that's why we depend on modern analytical tools and all. Transferring data from one place to another, or from one device to another, from one hard disk to another, and all. Visualization. How will you represent this data? So huge amounts of data is huge amount of data is there. How will you represent it? You don't have to show the complete entire data. You have to show only the filtered data. I'm sorry, guys. Just had to mute my mic because you could see my cursor, right? So I didn't want you guys to hear any disturbance. Privacy violations. So some companies might have company data or medical data, something with them which is very personal, or employee data which shouldn't be shared publicly, that might get leaked. So privacy violation. Big data creates big privacy and security concerns. Data growth rate. So this much data is being growing completely. So if you've seen that data growth rate, uh, 10-20 years before it might be very less, but now it's too much, like huge. So how will maintain it? So challenge is separating valuable knowledge from noise. So whatever the data is generated, some kachra and all bakkas will also be there. How will you filter it? You have to only keep the meaningful. So that is data growth rate. In this growing data huge, so too much data is being generated. In that, how will you separate valuable knowledge? And the last, oh sorry, there are still three more. Okay. So cloud hosting dilemma. So benefit, wait. Okay, so cloud hosting dilemma, cost effective, elastic scaling. This is also a challenge. So here, data stored outside company firewall raises security concerns. Trusting third-party cloud providers. So this is the challenge which you have here. Data retention. How long should data be kept? So should it be kept forever? If you keep it forever, then the storage it will always keep increasing. So you can't reduce anything. So that is also wrong. Defining appropriate retention policies. Some data is not required for retention. For example, if you had a bulk of data and you already gathered all the meaningful information from it and nothing else is there to extract, just let go of that data. So you have already the filter data. Right? Defining appropriate retention policies, balancing the data, etc. etc. Then you have skills storage. Problems to a shortage of qualified data scientists, data engineers, and BDA architectures. Demand for data scientists, okay. Skills needed, statistics problem. So this is also so here you can say challenge demand and all. Okay, say demand and all. Then what is big data analytics? Explain calculation of analytics. So big data analytics, it's just like a process of examining large data sets using advanced tool to uncover patterns, correlation, insight. Or you can also tell that to find the meaningful information or extract meaningful information from the data, but it is not very high quality words. You have to use this oh, see, uncover, see, decision making as well, and then you have to literally mention all these four key features even though you don't explain. So technology enabled, in a sense you can simply talk about the modern concepts. So you have Hadoop, Spark and all in your syllabus, so all you can easily mention these two, right? Move code to data. So here main thing is paradigm. In earlier cases, what used to happen, we used to take data to process it. So understand a software which will analyze the data and the data which has to be analyzed. In modern, in previous time, you had to take this data towards the software and then analyze. But now you don't have to do that. You can simply send this software to where the data actually lives and do what to say, analyze it. The program sent to data login. See, real-time decisions, fraud detection, recommendation, business values. So this is all the data analytics thing. Classification, we have four types. The descriptive analytics, just remember this, what happened. So this is like collecting all the information about the history in the past, what happens and all. You won't talk anything else, just what has happened in the past, why it happened, what's the reason, that and all. You don't have to talk about descriptive. So focus historical data. Then diagnostic analytics, why did it happen? See, why, what, why. And this is future. Okay, this is you are trying to reason what is happening, and this predictive analysis is future, what will happen. Okay, so from the based on the previous data, now what can happen, what will happen. Then you have what should we do. So we know what will happen. So if it is good, what should we do to make it more better? If it is bad, what should we do to prevent this bad to happen? So what should we do based on the acquired data we have? Just read this small thing. See, historical data analysis, what happened in the past, report, database short. So whatever you can think of. So if you have to talk about something which is already in past, what kind of data is already in the past, like news articles and all, so many things, reports, statistics, dashboards, it's all are once made, it is all past. Example, monthly sales report, website traffic analysis, fine. Okay. Tools, Excel, Tableau, Power BI. So remember about Tableau and Power BI, automatically you can talk about dashboards and reports. Okay, if you talk about these two, and if you talk about this two, obviously they have overcome Excel. It's advanced form like that. Why did it happen? Just see into that, you will understand. So finished. You don't have to talk about evolution analysis. Just can talk about earlierly it was only 1.2. In 1.2 it was only descriptive analytics. Here in 2.2 you had descriptive plus prescriptive. In 3.2 you had all three types, descriptive, prescriptive and predictive analysis. Also this prescriptive, predictive, oh sorry, and the first thing it was descriptive and diagnostic. Okay, what plus y. See, what plus descriptive and diagnostic. See, it's already here, you just have to remember this. Just talk about this. Okay, finish. Comparison table, it's not much required. Diagram, it's not there here. Anyways, we'll move on. You can check the textbook for that. So the too much was there, but it is not required. Already 8 pages over for two questions. Question 2, that was 10 marks question for both. Cap theorem, you just have to define the cap theorem, also called as Brewer's theorem, states that any distributed database system you can strongly guarantee only 2 or 3 properties simultaneously. This is very easy to remember, because in CAP only the system can either have CA or CP or AP. So what is consistency? Uh, every read operation receive the most recent write or an error. So no matter what you do, whenever you try to read, it has to show you the latest return thing. Availability, no matter what, I mean, if it is a failure, you have to get a response from the system. Partitioning, partition tolerance. System continues to function despite network failures or message loss. Okay, all these three things, just see about this. Remember the meaning and remember the example. If you once read this, you don't have to write everything, but just understand, see the source from where I have taken this, and then just explain, and then you say the trade-off, pick any two. So it can either be consistent, so it's very simple, right? You just have to repeat. Consistency means what? It has to show the latest thing, and availability, no matter what, even if a node fails, it has to give a response. No partition tolerance. Same thing, whatever it is group, just show them and finish. The real world analogy is for you to understand, not necessarily to be written in the answer, but it's your, which is 5 marks, so you don't have to write any real world example. Here, what is NewSQL? Explain the characters of NewSQL. So NewSQL is like combination of SQL and NoSQL. So SQL and NoSQL, it's a combination of that. So if in NoSQL, what is happening, that you cannot provide the advantages and benefits of SQL, like ACID transaction and all. But NoSQL doesn't support that. But we want it to happen, so that's why I'm saying NewSQL is a class of modern relational database management system, a modern DBMS that aims to provide the, see, I'll just the database, so this is DBM, anyways, provide the scalability of what is the advantage of NoSQL, that instead of going, oh, hello, 1 second, instead of in SQL it is like one layer over, it's like upgrade, it will keep on increasing, but in NoSQL at the same place you can introduce multiple nodes whenever you want. It's like that. So that's why the thing is the scalability of NoSQL while maintaining asset transactions guarantees and relational model of traditional SQL. See, scalability of NoSQL. Just remember, okay, the need for NoSQL, it's not that important. Why do we need? Just remember these three things. Okay. NoSQL like horizontal scalability, SQL like asset compliance, relational model support. Then characteristics of NoSQL, what they have asked, characteristics. So we can assume that among the 7 marks, 2 marks can easily be given for what is NoSQL. If we give 1 mark, then we have to state out some 6 characteristics, right? So we have 7 characteristics. So first characteristic is full asset transaction. Just talk about the full form of the ACID, atomicity, consistency, isolation, durability. That's it. And their relational model and SQL interface maintains traditional relational database structure, tables, rows, column, supports standard SQL case. So you just have to talk about SQL over here, in which it has table, rows, and columns. Just talk about SQL. Okay, and shared nothing artisan in the sense what, it doesn't rely on anything, it won't share anything, so it has its own independent CPU, memory, and disk. It won't be sharing anything, so there's no single point of failure. If one fails, it won't affect the other. Very high per node performance. So every node, since it has its own everything, multi-core CPUs, HD, so it doesn't have, it always gives you very high performance. See, optimize for modern hardware, in-memory processing capabilities, efficient query execution, benefit, handles high transaction volumes. Okay, non-blocking concurrency, reads and write don't block. In some in the earlier cases, what happens, if you have to write, the read would be block. If you want to read, the write would block. So because if I'm reading already, you cannot just snatch and write it. If you are writing something, you cannot snatch from you the book and read it, or like that, right? But no, it's not like that. You can write in the background automatically, and it will be updated. So if you are reading, it won't be interrupted. So non-blocking concurrency, remember, read and write does not block each other. OLTP and OLAP support online transaction platform and analytical processing. So real-time transaction handling, complex. So I'll just complex analytical queries more than enough. Medium schema rigidity, more flexible than traditional SQL. See, just more flexible. You can write more structured than, see, more flexible and more structured. One by SQL, one by NoSQL. Okay. Comparison table. This is not required, but you can see it for understanding. NoSQL doesn't have asset transaction, but SQL has. So that's why he also have. No, it's like if one is yes, no, automatically this will be S. So here it is very rigid, it is flexible. So we have to take the middle part. So schema, medium schema, scalability, it scale out. It follows, NoSQL all thing. Just see advantages and use case. It's your wish to. I don't think it's actually necessary to mention because it's not for 10 months. If it was 10 months, you had to mention it. Finished. Explain the Hadoop ecosystem components for data processing and data analytics. So see, Hadoop ecosystem components are for 3 things. One is data ingestion, then you have data analytics and data processing. Okay, one of the thing comes first, I don't know, but first thing data ingestion, which is talk about scoop and all. But here it has told only about these two things. So actual component consists of so many things: Hadoop, HDFS, you have Pig, Spark, Mahout, and something Hive, and some Uzi and all. It's there in the diagram, textbook diagram. But here you just have to talk about what? Only data processing, data analytics. It's very simple. Introduction: Hadoop ecosystem is a collection of open source tools. See, it's all ecosystem is a collection. Always remember, collection of open source tools and frameworks. Okay, that work together to store, process, and analyze big data. See, what we do with big data, we collect them, we store them, we analyze them, we process them, and analyze. Okay, so that's what we are using. All the collection of these open framework tools, what they do, okay, they do these things. Okay, it extends Hadoop. Say, okay, it extends core Hadoop, HDFS, MapReduce, and that's what you have to talk. Data processing components. You have to talk about MapReduce and Apex Spark. MapReduce is a very simple program in which you divide the input into key value pairs, and then in the reduce phase you aggregate or remove the duplicate values and you just process it. So whatever the data is taken, it will be divided among multiple slaves and run in parallel. Okay. Just see about this. And now API Spark open source in-memory computing. You have to remember this main thing. Open source in-memory computing framework for fast, big, and data processing. It's like, just remember Spark, like suddenly a lightning bolt spark, like whatever it is. You know that lighter inside thing we used to play in our childhood. That spark. So it's about that, like very fast, right? So you have to remember about speed, real time. Just see this key feature. That's it, more than enough, bro. Nothing else is required. If you want, it uses Spark SQL query language, Spark streaming ML. You can just mention about this one thing. Okay, that's it. Then data analytical components. You have Apache Pig and Apache Hive. So see here, you will be discussing about this in the module 4. So I won't be explaining about that here, but just remember whatever you remember from module 4, you just have to fill it out here. Along with the Pig and Hive, you have to talk about Impala. Impala is very small, high performance SQL engine. So remember, high performance SQL engine for interactive queries on Hadoop. So characters, just remember this four thing mentioned. Over, finish. That's it. The question is done. What was the marks of this question? Let us check once again. 8 marks. So what we have done, we have explained this. Let us keep it. Explain Hadoop ecosystem components. Oh, directly have. So this is basically data processing for 4 marks, data analytics 4 marks. So basically what happening? Map produce 2 marks, Apache Sparks 2 marks, Pig 2 mark, and Hive 2 marks. That's it. Then we'll move to the next question. Oh, so you have Impala here additional, so it's very easy to gain marks over here. Model 2. Okay, so with the need diagram, explain HDFS architecture. So actually we have taken a lot of time. Anyways, HDFS architecture will do. You basically have I paste the diagram. See, you have to talk about client. You have to talk about name node. You have to talk about data node. This is the actual block of data. Okay, it's not, okay. See, I'll do like this. So here block of data. So each sample text is taken as input. It is divided into different blocks, and each block will what happen, it will be given a data node. So each block will be having 3 copies. So that's what. So each block will be having a node. See, node is name node, so particular name node for each block, and it will be here what is happening, why these 3 arrows in the sense, it will be updating everything. So it is monitoring it, what is happening, where it is what. So just knowledge. Each block, see, ABC, 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 3 replications happening. That's what it is. So what you have to talk about architecture. Where is it, man? Yeah. See, first just explain about architecture. HDFS storage component which sits on Hadoop. That stores massive file across multiple machines. I'll just talk about HDFS directly. Master slave. HDFS is nothing but a master slave model. You have to talk about the client which actually submits the job and all. Name node brain. You have to mention this brain of the HDFS. This is responsibilities. Breaks files into blocks. Whatever the input is given, divides into block. We saw in the block A, block B, block C. Track block locations. So name node are assigned for this. So each block will be known where it is. Manages namespace. Handles file system. Handles file operation. Create, read, write, delete. Rack awareness. Knows in which part of rack the data node is shared. Then this is more very important. You have to mention about this for enough over about name node. That nothing else is required. Data node, you just have to talk about these 4 key points. Stores actual data blocks. That's it. And main thing, it keeps on sending heartbeats and all. After 10 minutes interval is there. In 10 minutes it doesn't send heartbeat. Over. Okay, so gone like that. Then you have secondary name node. It's like if the primary actual name node fails, the secondary name node is used as a backup, but it won't be automatically triggered. It has to be done manually. See, it's not hot standby. In the sense, automatic won't have manual recovery is required. Say it what it does, whatever the name node has done, right? It will keep on taking the snapshots of what it is done, but it won't be taking snapshots of real time. Only the already stored one. That's it. Over. Characteristics your wish to write. If it is for 10 marks, we'll see is it for 10 marks. It is for 8 marks, so you don't have to explain much about that. We'll just finish and move on to the next question. um, Application strategy. So you can talk about this if you want. Replication strategy where basically in system 2 replication count will be there, but here we use 3 in the sense what we'll be doing 3 replication. Question 3b, HDFS daemons. Bro, it's the easiest part of question. Why? Because HDF daemons is nothing but name node, data node, and secondary name node. So it's literally whatever you have explained here, you will be repeating over here. I don't know which stupid has made this question in model question paper, but it's the same thing you do over. Okay, I won't be explaining that. Mm, yeah, see, this is a diagram of name node, data node communication. How name node handles all the data nodes. It will keep on sending heartbeats, everything. So same name node, suddenly no heartbeat is given back, so it will you get lost, bro. I like, oh, he's done, Papa, so he'll send someone else to take care of that. See, give HDFS commands to perform the following operations. You have, see, okay, required operations. First, to get the list of directories and files at the root of HDFS. Hadoop fs slash ls. Very simple, very one line. That's it. To create a directory, say sample in HDFS. HDFS fs mkdir sample. So, see, Hadoop fs. I'll put array. Hadoop FS. Hadoop FS is big. It's mandatory to be there. After that, to list the directories is list list. So only lis. So listing the directories. To create a mkdir. So it's a basic thing which you in terminal slash the name of the thing sample. To copy a file from local file system to HDFS. Hadoop FS. See, put. Okay. So, put is nothing but basically like actually copy and paste. So this is a copy paste. Oh, so see, put directly. So whatever it is there, or okay, see, we will see this one. Hadoop FS copy from local, whatever the root it was there. Say what here it's very simple, bro. Here you can literally write if they have not given an example. It's just one example. So you can take user and sample text.txt slash sample text.txt. So this is not required. Okay, this is not required. Till here you can finish. It's like your whatever. If I don't know whether it shows. If I go to any documents here, desktop. If I tap here, see user Rehan desktop 77 BDA like that. Just have to put anything to display the content of HDFS files on it. So this is mandatory. Cat content, what is that, concatenation, I don't know, sample.txt. So whatever you want to display, you just have to remember this thing in the same file path you have showing here. Additional usage command, download file from. So here I think the only 4 was asked in the question paper, right? I don't know whether this will be opened or not. Oh, let me just check. Yeah, so display the account. So oh, it's only for 4 marks. Man, get lost. We don't want this additional. You can check in the description after that. MongoDB, man, this is the easiest module and of this complete subject. So what is MongoDB? Modern NoSQL database with 6 key data. Directly, literally, you will just tell modern database, relational database, NoSQL wala with 6 things. Class platform, works on all the platforms, open source, free to use, non-relational, no tables and all like that. How SQL is distributed, runs across multiple platforms. See, same thing. Can we work on that and runs across multiple servers and scalability? No SQL uses MongoDB query language instead of SQL. Document oriented, store data as JSON like document in the sense what, but here we will storing a in the sense what, whatever you get as it is, document will be stored. BSN is nothing but binary type. Okay, why MongoDB? There are problems with RDMS. See, these 3 things: large volume of data, it can't be handled by RDMS. Rich variety of data, like only structured data it handles, but unstructured cannot be handled. Scale requirements, it's not scalable. That's why we take MongoDB. We have 10 key features actually on big diagram. Auto sharding, in the sense dividing, automatically sharing storing the data, distributing across multiple server. Document oriented storage, natural data representation like JSON, BSN. Okay, full index support, indexes on any field. So everything you enter, every document or field you enter will have its unique, primary key. Either you can give this manually or automatically it will having. So whatever you have to query, with the help of this index, it's very easy to query very fast. See, fast query. High performance, optimal for fees, in-memory operation, efficient data structures, fast in-place updates, update data where it exists. So you don't have to copy the data up, update and then store directly wherever the data is, directly update over there, change, do the modifications over there. Rich query language, expressive queries similar to SQL, support complex filtering, sorting, aggregation. So you have to talk about what kind of queries you can be, like aggregator, grouping, sorting, filtering type of queries are there, which can be dynamic queries and all. Replication, how it replicates and stores it. Easy scalability, wherever you want add the node without downtime. Horizontal scaling, see, horizontal scaling, wherever you want add node. High availability, no single point of failure because of replication. Grid FS or binary storage, stores large files. Finish, man. Hey, what was the question again? What is MongoDB? Why MongoDB? Illustrate the process of creating or generating a unique key. What? It has to be for 10 marks. Yeah, see. Because this is one line. You just have to. This can be for 2 marks. Why MongoDB? It should be easily for 5 to 6 marks. So remaining is for 3 marks. So this has to be for 3 marks. Cannot, because this is actually very big, because it has 10 entire things within it. So it has to be at least minimum for 4 marks or 6, 4 to 6. Where is it? Illustrating. So about illustrating the process of creating or generating a unique key, the ID field. So this is the nothing but, so if you actually check in the video where I have explained Mongo query, so you can say that object ID and all it is there. Either you manually create it or auto generated. Provide your own unique values, or MongoDB shell generates object ID automatically. So you have to talk about these 4 things, very important over here. These 4 things are also explained over here. Why this design is not necessary to write off, but here process. So get current timestamp, get machine identifier, get process ID, increment counter. See, this is 6 steps. You can just see and understand. So here see JavaScript db.students.insert id 1, name John. This is just a single query in which directly I can say that underscore id is 1. Whatever id I want, I can give. Auto generator, you don't mention that, automatically it will generate. It's very easy and simple, bro. But you have to talk. See, remember this thing, and you have to mention about this. Where is that? 4 things: timestamp, machine ID, process ID, can counter. Next question: implement functions, count, sort, limit. So this is just function. You can just see and finish. Instead of seeing the whole thing, you can just go to the last part of the answer and where is it, bro? Um, all in one example was here. So see, too much I have given over here. So we can just see the last part and finish it. Then module 3, explain the following methods with an example for each. So saving, finding, pretty, count, skip. So pretty is pretty and find are kind of same. So whenever you use find to display many documents, it will be displayed. Sometimes it won't be displayed, very neatly. That's why you say find, put like this dot pretty. So pretty will format the data. It's very safe. Saving is just same method. What we are, insert a new document or update as the extension. So you have to talk about insert and update in saving. See, student dot save, so it will be saved. So write result inserted. Then you have update, save, changed hobby. You can just simply talk about insert and update instead of save. Find method, you just have to find one and find. You don't have find many, because find is automatically finding everything. Uh, Pretty, see, display query result in formatted readable JSON format. That's what I told you now. See, find dot pretty will just make it look like very good thing. So count, count query, count all documents. So students also, this is the collection. Okay, within this collection, I might have added multiple users. So just count. So how many users is there? It will just count. What, man? Just so easy. Count with multiple. So count. You can either count directly all the documents, or you can give a specific queries like count whoever is having the hobbies of this particular hobbies, or count with whoever is having the grade or CGPA greater than 9.0. So you have set of students with particular CGPAs, you can easily count them. It's just like that. Skip method specified number of documents and returns the rest. Okay, so it's like whoever is hobby is computer science, just skip them, just remove them, show me all other people. It's very easy to do this one. You can simply use the find thing. In the find you can simply give the parameter like find not equal to computer science, so automatically it will show whoever is not having computer science. Skip is basically doing the same. So if you have to skip computer science, it will specify number of documents and return the rest. So whatever you have to skip particularly, it will be skipped and others will be shown. But in skip, what is happening in find, if you have to put not equal to computer science, it will only take what to say, computer science. But here we can take randomly anything, so flexibility is over here. So here sample data, student roll number, student name. So here we have skipped skip, and so particular 5, so only 5 will be shown and remaining all will be shown. Skipped documents, skip first 2 documents. Oh, so skip 2 means first 2 will be skipped. Okay, skip and nothing will be it's just a very simple. And here give a collection which bro, this actually is very easiest question. But if I don't know you want me to explain this or not, but if you want, I'll explain this in the thing, what to say, our terminal. Skip this question. Hive, yeah, 10 marks. What is Hive? List the features of Hive. So you have to talk about whenever you say Hive, you have to add this word automatically. It's a data warehouse tool, sits on top of Hadoop to process structured data. Okay, so process structured data. It provides a SQL-like interface for querying massive data sets stored in HDFS without writing complex MapReduce. So basically, why Hive and Pig is used, that MapReduce coding is complex. That's why instead of that, we will be using Hive QL queries to store massive data. So Hive building blocks: HDF, MapReduce, RDMMS. It uses HDFS for storage, MapReduce for execution. Basically, Hive does not execute anything. It will just write the query, and which will be automatically converted to MapReduce functions, and then it will be executed. What Hive is, so see, basically if you cannot understand this explanation, you can just see here. It is a data warehouse application which sits on top of HDFS. It uses batch processing. Okay, it also supports OLAP, on analytic process, log and say example. Okay, that's it. What Hive is not, it is not an RDBS, not designed for OLTP, not designed for real-time queries, not designed for roll-over updates. Features of Hive, see, similar to SQL. So if whoever knows SQL, then you can easily use Hive QL query. Easy to code. See, no need to write complex code, very simple code. Rich data type. So you have this particular data type: struct, array, and map. So it can be used in Hive. Standard SQL conventions, whatever SQL is offering, Hive can also use it for querying and all. Extensible, define custom data. Extensible, in which you can define your own, uh, custom functions and custom types, data types, where user define. That's it. Over. You don't have to talk about the brief history and all. Just leave it. Explain Hive file format. You have text file format, then sequential file format, and you have RC file format. So text file format is storing line by line as it is, whatever comes on and all. Sequential here binary key value, so all zeros and one. And RC file is a record columnar. So whatever is given, it will be first 1, 2, 3, 4, 5, one column over. So column by column, then it will come here. Understood? So here 1, 2, 3, 4, 5, 6, 7, 8, 9, like that. Explanation, just see for yourself. Then explain bucketing with the example. I'll just explain what is bucketing. And bucketing is basically like whatever data you is having, instead of, it's like filtering thing. So what do? You use a particular hash function to bucket the things into particular bucket. So you have to set the bucket number like 3 buckets or 4 buckets. So in the sense, 4 columns. So it will be segregated and stored in that. So partitioning or bucketing, this what to say, this is not required. What do mean this comparison is not required? See, bucketing distributes data into fixed number of files using hash function. These files are nothing but fixed number of buckets that are actually as columns. Okay, then how bucketing works? What was the question? Explain bucketing with an example. How bucketing works, you can just see here. I told you, right? Suppose input data is see, ID, name, and CGP. Understood? Hash distribution, hash what is it? Percentage 3 equals to 0. Oh, okay. Hash 3.2. 3 modulo 3 is 0. No reminder. One reminder. Here, if you do, what is it? Why is it 2 reminder? So, result file student with grade 3, 0.0, 3.5. Uh, 1 student to 4, 4.2, 5. So, here it has divided based on this hash values and all. Which I got. Okay. One example is this is the example in textbook is a more better example. I should have given better example. It is there in the notes. Where is the resource? It has not mentioned. I'm pretty sure that this belongs from chapter 5.1 textbook. So you can see that BDA module 4, chapter 5, if I'm not wrong, 5.1 to 5.8, something like that. Hope packeting was over. What is Pig? Features of Pig. Okay, high level platform analyzer. Very simple and key feature. Directly just explain the four key features. It's also 4 marks through. See, data flow engine, Pig Latin language, built-in operator, UFD. Here also you can do user defined function like Hive. Much things are like Hive. See here, join, filter, group, order. So these are some, good query, rich query language over there, but here built-in operators already. Pig Latin language. So you have, what is that? Pig Latin. So it is the query language. Very simple to write, very understanding. Within it, explain the anatomy of pig. So in anatomy of pig, wait, I had paste the diagram, or I didn't. Anyways, in anatomy of pig, let me just show you. Wait. Ah, anatomy of pig. Yeah, so here is anatomy. First you have pig Latin script. You just draw like this. Okay, one box, two box. Oh, what the hell was that? Yeah. Yo, what hey, something bugging. So here you have to write pig script. This is the pig interpreter. At the last you have Hadoop cluster. Yeah, Hadoop cluster in which MapReduce jobs with it. So basically, what is happening? Not first you write the code and all in the Pig Latin right now. For example, A is equals to load data, B is equals to filter A by GPA. So load data can be like load A is equals to load A as name comma CGPA comma something. It's there in the diagram. Then store B into output something very useful. Pig interpreter, what it does, parser, type checker, optimizer, log plan, generator, so many things are here, but those many things are not actually required. What it does, it checks the Latin pig query, Latin language, any errors are there or not, then it corrects it, and then it makes it ready to get executed. So in Hadoop cluster, the map reduce jobs are there, it will be executed over there. That's all I have to tell. See, checks syntax of the code, type checker, validates data types, optimize execution plan. Logical plan, create DAG of operation. What is DAG? I don't know. You can comment it. Physical plan maps to map reduce stages, generates Java codes, submits jobs to Hadoop. That's it. So see here is basic thing. You have to. It's very easy to understand. If you want to cook something, see recipe. It is the actual recipe what have to be done. Chef is the interpreter who will be cooking in the kitchen is nothing but Hadoop where the cooking is happening. Okay, chef, I very interesting. Explain any 5 relational operators of pig with an example. So, like filter, you can see, bro, very easy, bro. Remember this only one line. You don't have to remember. Say A is equals to load any file name. Just give any file name. It's not necessary to be something particular. Any file name as in the bracket. Just give the fields. You can simply say the roll number is integer, name is character, and GPA, CGPA as float. Then B is equals to filter A by CGPA greater than 4. Dump B. That's it. Over. Finished. You can simply write an example. Suppose we had, just write 101, 102, 103, multiple name. Their CGPA was less than 4. Here they have greater than 4. Just write them. For each, transform columns. So load same thing. See, if again always the same. B is equals to for each A generate upper name. So what will happen for every name? It will become capital letters. All are capital letters. So for each A generate upper. Very simple. Over. So see they became capital. Group doubles by field. See again same load. Everything is same. Group A by GPA. Dump. So what will happen? Whatever the actual fields are there, it will be grouped by this. Whatever you have inside this it will be so for example see they are different, no, they are different. So what is, you have 6 fields, Think of it. So here it was 3, here it was 4, and suppose it is 5. So 3, 4, 5, 4, 5, 2 are in 4 and only 1 is 3. So you will be grouping them. So first only 3 CPU, how many are there? Only 1 are there. 4 CPU, how many are there? 2 are there. 4.5 CPU, how many are there? 2 are there. Like that. Order by sort data. See, again everything is same, man. Order A by GPA. DESE. What is DESE? Yeah. Descending order. Yeah. Dump B. So see, higher to lower, descending order. Join combines two relations. A. So what you are doing? You are loading two data now. So what were you doing as load? A equals to load, so you have to do the same with B. C equals to join A by roll number, comma B by roll number. Why are you taking B itself? Dumb C. So both of their what to say? Both of them will be joined using the roll number thing. So 101 join. So let us see here. So this is A obviously, and here this is B 102 comma B tech. Department char array. Department is int. Roll number int. So name. This is GPA. So all A characters are here. Roll number int, department int. Oh, not only is the department, department name VE. Oh, basically the whatever both have been just joined. So we see, bro, it's very easy. Remember one thing. It's the other thing is very easy. Module 5 compact answer. Okay. Oh, we have already completed 4 modules. This is the last. Man, it's 40 minutes. Too much, bro. Question 9. With a new diagram, explain the main feature of Spark. Ah, man, I'm not going with this Spark because I literally hate it. Yeah, because it's too much and too complicated. Explain the. Oh, actually, I had this should be text pre-processing. Yeah. See, this is the easiest question which can be asked from Module 5 is about with a neat diagram, explain text mining process and also web mining the same way. And then you have page ranking system. In text mining, you have to talk about 5 phases. See, text pre-processing. So you're just cleaning the data. Feature generation and feature selection. See, feature generation, feature selection. This is same. Then what you will do in data mining, clustering and classification. You should talk about two things. I don't remember, but I remember you have to talk about naive base and vector base something. Okay, that's it. And analyze nothing but keeping collect displaying the data, showing the data. That's it. Over. I won't be talking much about that. Yeah, explain the page rank algorithm using the relative authority of parents who use over linked. This, bro, just study by yourself because this particular topic I did not study by myself or explain, but you can just see it. Okay, I hope this was very useful and let's see.